Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be building an NTP clock using a Raspberry Pi. This is building upon the Linux installation that we did with Alpine Linux last time. So if you want to check out that video first, click this link right here. But let's go ahead and get into it. We're about to get extended. So before we get started, let's just kind of go through the script that we have. So I've already pre-written the script. It's in Python. And what it's going to do is do a console text-based output of the current time. It's going to update it every second, and it's going to actually synchronize to NTP using the Crony NTP client that we installed with the installation of Alpine Linux last time. So just taking a look at the script. It's about 200 lines long, and we're not going to go through the whole thing just to keep everything kind of simple. But we have a number of import statements. We have a restore cursor, so it's going to hide the cursor when it starts, and then it's going to restore it after it exits through a callback. It has some height filler in order to center the actual clock vertically. It's also going to tell us the IP address. That way, when we're looking at the clock, if we don't remember it or if we have it assigned through DHCP, we can actually determine what that is if we need to make updates or changes to the configuration. Then we see it actually parses the configuration itself. And the config file is very simple. And this is the example of the template config file that's loaded when the actual script is loaded. It sets the time zone. It also sets the color for the foreground color and background color during the day, as well as a second definition of foreground and background color for at night. So what this is actually going to do is, after sunset, it's going to change to a different color. And in this case, I chose a darker blue. So that way, if you have it in like a bedroom or somewhere else like that, it's not going to keep you up with a bright light or anything like that. It's going to automatically dim to make it more ergonomic. And to define what that sunrise and sunset is, we have the location defined as well, where we have a city, a region, a latitude, and a longitude defined. So back to the script. We see that the time zone is initialized here, and then we actually determine what the actual size of the screen is in terms of rows and columns. Because this is in text mode, the individual cells are 8 pixels wide by 16 pixels tall, and that makes up an individual cell. So it finds out how many rows and columns of those cells are actually available to be able to determine how to center it. In the event it can't do that, it just defaults to a 30 by 100 just to keep everything running. Skipping forward, we see that we're using Astral in order to actually determine what the sunrise and sunset time is. So we define the location here using the config parameters. And we also load in our foreground and background colors. The IP address is called through a function, so we initialize that here. And what the actual getIP function is doing is it's determining what the default gateway is, and then choosing the IP address of the interface that is attached to that. So it should be the most accessible one, since there should only be one default gateway on any given machine, as far as proper networking procedure. So it's going to choose that interface since it can only show one. From here, it goes into an infinite loop, so it will loop forever. And we see it sets the sunrise and sunset times currently. And then if the date time is after sunrise and before sunset, then it's obviously going to be day. So it sets parameters appropriately. And if it's not, it's night. So then it goes into the output mode. It initializes the output variables in order to make sure that there's some form of display available. And then it will check to see if there's a format change. So if there's a format change, so like if you resize the screen, because you can display this in an SSH terminal, you actually need to clear the entire screen in order to redraw it. So that way you don't have artifacts of whatever you had previously still showing on the screen. So if it's not a format change and it's the same screen, it will actually backspace the certain number of heights, or the height of the actual text, in order to improve the refresh. The problem is when you actually refresh and clear the entire screen, you get a flicker in the output image. But because we're going to be updating this every second, that's going to be potentially difficult, make it difficult to read the clock. So what we're going to do is we're just going to actually use this special character, which is the \033 close bracket F, and that will actually go up a line using a hidden character instead of redrawing it. So we're just overwriting the text that's there. We're never actually erasing it, and that prevents the flicker. Going down here, we draw out the IP address, and then we determine how much filler that we need before we actually draw the clock. So for the quick clock, that means that any time that we have a refresh event, something like that, and it's not expecting to draw the entire screen, we want to display the clock as quick as possible. And the reason is, in order to maintain synchronization across multiple instances of these clocks, so if you install multiple devices, we want all the second hands to tick together on the second. So we have a small little loop, or a small little if statement here, that waits to see how much time is left in the second before the next second and sleeps for that amount of time. If we did that when we were drawing the whole screen, we'd miss that entire second. So we want to be able to skip that if need be, and that's what quick clock does. So when we first enter this, it does that. And we see it does the backspace operation in order to get to the top of the text. And next we output the actual time string. And what we've done is we've defined a number, okay, or an indexed list associated with the actual output that uses a special character that shows a full block over that cell. So it's an 8x16 block, solid block. And there's one layout for each number, and the number is correlated to the index of the number it's supposed to display. So what we do is we take the actual output of the time, and we go through it character by character to be able to use that as an index. So if it's a number, we'll use that as the index for the list to actually populate and copy that number into our output variable. If it's not, if it's a colon, we'll use the definition of the colon. And if it's a period, just because we're using to separate minutes and seconds, we're going to use a period instead of another colon, just to make it easier to read. We'll copy that into the output variable. Then we'll actually take all of the output, center it accordingly on the screen, at least horizontally since we've already done the vertical centering, and we will print it to the screen. We also include the full date, so that way you can see what the date is in addition to the time, but that's just going to appear as normal text. Going from there, we will actually determine if it's the first second of the minute. And this will only happen once, so it sets a variable to make sure it's not looping infinitely during that second, which will save power and save processing time. But we want to actually redraw the entire screen just to make sure everything's staying consistent in case there's some errors or something like that that's popped up. Since it's not actual video or anything else like that, it's just text, there's a possibility that if there's console errors that pop up or something of that nature, it could interfere with the display of the screen and cause some ghosting or other things that would be rectified just by refreshing and redrawing the entire screen. So this takes care of that. And then we have our width and height detection, just to see if the screen has changed. That occurs every second, as well as a few other things like sunrise and sunset time. So if it detects a change, it will redraw the entire screen to use the new color scheme. And same thing with IP address. We want to update that if it changes, so this takes care of that. And that's the end of the script. So it's about 188 lines, which is not very much. Now, in order to run this on boot, we're actually going to use an init function. And the init function is pretty generic. I've written this so it just starts the process and kills the process in order to be able to start, restart it, etc. But it's using whatever the name of the actual init is, so you can actually apply this to your own scripts to make it start up as well. So we're going to leave that just as an overview, but this is pretty much the default that's defined for Alpine Linux as their example with a few modifications. Now, to install all of this, I've tried to make it as easy as possible for anybody who's just getting started. So I'm going to post all this code to a GitHub, and included with that is the install script. And what this will do is it will actually go through, it will remove a hashtag that comments out the community string, which has some of the packages that we need for using APK in order to be able to make sure that we're able to access the packages that we need to install in order to use this, specifically pip in this case. We then update and we pull down Python 3 and Python 3 pip. And pip is the package installer for Python. Now, we do need to build some of these packages, so we have build base, Python 3 dev, and Linux headers as well, but we'll remove those in a second after we build it. But we call pip3 in order to install Python time zone, colored, which allows us to do the color text on the console, cursor, which allows us to control hiding the cursor and revealing it once it exits, astral, which determines our sunrise and sunset time, as well as netafaces, which is net interfaces. It's effectively getting our network IP for us. So once that's all installed, we can actually go and delete the build base Python 3 dev and Linux headers in order to keep the footprint as small as possible. From there, it's going to copy the respective files that we just reviewed, as well as a few other ones, create the config directory, etc., as well as including an example user config.txt file. And the user config.txt is used if you actually want to change the resolution of the monitor and define it as on startup to be something so it displays more appropriately, displays larger, things of that nature. So I've included a few commands here, and you can research these by Googling them, the commands individually, to determine what's the best value for you. But I put one here that it correlates to this display, which is a 800 across by 480 tall. And zooming it in, so doing a frame buffer, and the frame buffer is the actual display that it's using to show on there, is 480 by 160, which makes the text very readable. We want that. That's the settings that I have included in the file that you'll see, but you can change those values to whatever you need to in order to make it work. Then we add those files to LBU. Remember, with Alpine Linux, anytime we restart, it's going to default back to the last saved settings. And in this case, since we're installing a number of files, that would clear and erase all of our files that we just installed. So we want to make sure that they're included to be saved the next time we commit an LBU save. So we're going to add those files here, including all of the libraries for Python, the site packages in particular, to make sure that those are preserved since we installed those as well. Next, we're going to want to chmod and change the permissions on the individual files that have to be executed in order to have executable permissions. So we do chmod plus X for executable, and we call all of the files that need to be executed. Then we register our init file using rc update. So we do rc update add NTP clock, which is the name of the init file that's already been copied and given executable permissions to that directory. And we say default, because we want it to run at the default run levels. And we're not going to get into what that specifically means, but it just means when you're generally able to use the computer is when it's going to be running. And then we will commit these changes using LBU commit. We then just echo and let the installer announce that it has finished the installation. And if it's not started, we'll start NTP clock. And if it is started, we'll restart NTP clock to apply changes. So you can always run this a second or third time. It should overwrite itself without creating a lot of other things in case there's changes in the future that you want to incorporate into your existing clocks. So let's go through and actually install this and just go through that procedure. So to load the actual files themselves, we're going to use FileZilla. It's just an FTP client, but it's compatible with doing FTP connections over SSH. So we're going to log into our Raspberry Pi Alpine Linux installation using the IP address that was assigned by the DHCP server. When the Pi first boots up, if it's already connected to a network, it should show what that IP address is on the screen, especially before we install any of the software that we're about to install. So in our case, I know this IP address. So next we need the username. If you followed the video that we made about installing and setting up Alpine Linux, we left the default username of root. So let's use that. And we also set a password at that time. So we'll use that as well. Now the critical thing is, because we're not using FTP or some other protocol, we need to define a port number to let it know what service to use. So for SSH, it's port 22. And then we can hit Quick Connect. And we see it logs us into the root directory. And in this case, root is referring to the user. So what I have here is, this is a zip file of the NTP clock. And you can make this just by downloading the files in the Git directory. It may even zip them for you, but we just want to copy this over. Once it's copied, we can actually close out of FileZilla. Next, we're going to use PuTTY, and PuTTY is just an SSH terminal program to be able to connect to remote computers and be able to manipulate them through command line. So in this case, I already have it installed, and we're going to put in that same IP address and connect to port 22, just like we did with FileZilla. When we hit open, it will load the command window. It'll ask us to log in. We're going to use the same login credentials we just used for FileZilla as well. Now in this case, I've already run this before, but you'll probably have a default prompt here. But this is an example of what's called the message of the day. And this will show you all of the basic commands that I've included in order to make sure that it's easy to remember what you need to do in order to administrate the clock, like changing configuration settings, where the user file is located and how to modify it, and also a few other things like setting NTP servers if you needed to set custom ones outside of the ones that were automatically selected when Crony was installed. So we're going to ignore this for now, but we're going to look at our present working directory, which is /root, which is where we dropped that file. So we're in the home directory for the root user. If we ls or list the contents of that directory, we can see that we have our zip file already in that folder. In order to unzip it, one of the default programs included without the Alpine Linux distribution that we chose is unzip. So to unzip it, we're going to type unzip and the name of the file. And what I did is I typed the first few letters and I hit the tab key to enable autocompletion. Autocompletion will allow it to choose the name of the file if it can determine it and if it's unique, and will write out the next characters in the name of the file in order to get to either the end of the name or to get to the next point where there's multiple files to choose from, and it will stop. So in this case, it writes out the whole file because it's the only file in the directory, but that is the one we want. So the command is unzip and the name of the file, and we hit enter. We see that it inflated it to within this directory that we're currently in. So if we now ls the same directory, we see that we have the installation script and a folder called root in addition to the zip file that we started with. So in order to run this, we're actually going to need to give the install script executable permissions. So we're going to type in chmod, so chmod space +x as in x-ray, and then the name of the file that we want to give the permissions to. So since this is the only file that has the lowercase NTP, I type that in, hit tab for autocompletion, and now the command is ready to run. So we hit enter. Now if we ls our script again, we see that it's turned green, indicating that it now has executable permissions. So let's go ahead and run it. In order to run this, we're gonna do a period, a /, and then the name of the file. And once again, we can use the tab for autocompletion. And then we just hit enter. And here we see it's proceeding. It's fetching the updated list. It's installing the needed packages. In this case, it's installing the files needed to build the pip packages, and then it's removing them and to try and clean up. Because this is already a previous installation, it says that it was already initialized as run level default, but it would have added it there, and then it would start it running. So now that we've completed the installation, we can see on the clock that we've created itself, we have the IP address shown up top, we have the current date, and we have the current time. And we see the time is incrementing successfully without flickering or anything else like that. And the blocks line up in order to create the output of the numbers. So it's a very effective clock and it's very stable. I use these at home in a lot of places in order to make sure that all my clocks sync together. And that way I don't have to keep adjusting them. And the nice thing about using a time zone offset is that it will automatically adjust for daylight savings time if it's applicable in your area. So you don't actually have to go through and update those clocks. They'll update automatically when those changes occur. So since we installed this using the script, we did save the configuration using LBU. So when we restart the actual Pi, it should automatically load into this program. So let's give that a try. So I'm disconnecting power here, and when I plug it back in, it's going to load. So here it is loading Alpine Linux. It's now booting into the OS, and in a certain point, it's going to reach the run level where it should start the actual clock, and it's going to do that. So it's synchronizing the time using Crony, and there it is. The clock loaded automatically. And it's very good. This is one of the reasons to use an embedded system in order to do functions like this, is we just want it to do one thing successfully and cleanly and be very low overhead in order to do it. The actual power consumption of this overall system is predominantly the screen and not the processing on the Pi needed to do it. So that makes a huge difference as far as overall long-term cost of use. as keeping costs low is definitely a priority for everyone. So I hope this inspires you to actually try this for yourself. If you'd like, I have placed the code on a GitHub, and you can check the description down below in order to get a link to that. Thanks for watching the video today. If you'd like to see more videos like this, check out this playlist right here. Also, if you liked the video, be sure to hit that like button and leave a comment down below. If you haven't subscribed, please subscribe, it helps me out a lot. And then hit that notification bell, that way you know the next time we're getting extended. So until then, take care.